In Lesson 1A, you will interpret graphs of functions and draw the graphs of functions. How can real-world situations be modeled using graphs and functions? The graph shows the relationship between blood flow to the brain and the number of days after the concussion. The graph shows that as the number of days increases, the percent of blood flow increases. The return of normal blood flow to the brain is said to be a function of the number of days since the concussion. A function is a relationship between input and output. In a function, the output depends on the input. There is exactly one output for each input. A function is graphed using a coordinate system. It is formed by the intersection of two number lines, the horizontal axis and the vertical axis. The vertical axis can also be called the y-axis, that's as we label it. The x-axis is the horizontal axis, and where they meet is 0, 0, the beginning or the origin. The coordinate system is also called the coordinate plane, and each point is named by an ordered pair, which starts with a parenthesis, the x part of the coordinate, comma, y part of the coordinate, and ends with the parenthesis. Each input x and its corresponding output y can be represented on a graph using ordered pairs. An ordered pair is a set of numbers or coordinates written in the form xy. The x value, called the x-coordinate, corresponds to the x-axis, and the y value, or the y-coordinate, corresponds to the y-axis. Name the ordered pair at point E and explain what it represents. To get to point E, we would move to 6 on the x-axis and up to 100 on the y-axis. So it's the ordered pair 6, 100. This represents 100% normal blood flow after 6 days after the injury. In example 1, the percent of normal blood flow depends on the number of days from injury. Therefore, the number of days from injury is called the independent variable, or quantity, and the percent of normal blood flow is called the dependent variable, or quantity. Usually, the independent variable is graphed on the horizontal axis, and the dependent variable is graphed on the vertical axis. In warm climates, the average amount of electricity used in homes each month rises as the daily average temperature increases and falls as the daily average temperature decreases. Identify the independent and dependent variables for this function. Well, the thing that's causing the change, the temperature increases, the temperature decreases. So that's going to be our independent variable. And they said the amount of energy used is what's changing because the temperature changes. So that's our dependent variable. The graph represents the temperature in Ms. Ling's classroom on a winter school day. Describe what is happening in the graph. Well, it looks like from some time it is warming up, and then it cools down, warms up, cools down, warms up, until the end of the day, then it cools down again. If you're in the part of the building that has radiator heat, you experience this more than my nice classroom that has a thermostat on the wall. So the temperature is low until the heat is turned on, then the temperature fluctuates up and down. Finally, the temperature drops when the heat is turned off. I don't know that most schools turn off their heat, but anyway, that's what the graph represents. Okay, imagine yourself in a big school. There are 3 lunch periods at a school cafeteria. During the first period, 352 students eat lunch. During the second period, 304 students eat lunch. During the third period, 391 students eat lunch. Make a table showing the number of students for each of the 3 lunch periods. Now that comes very naturally to us. We want to see it as a table. It's easy to relate the period to the number of students eating. Okay, now they want the same data as a set of ordered pairs, so we could write that as 1, 352. 2, 304, and 3, 391. Now we wrote the period number first because that is the independent variable, and the number of students depends on what period it is, so that is the dependent variable. Okay, third representation of the same data, they want a graph that shows the relationship between the lunch period and the number of students. Now they used a little squiggle here. That's called a little interrupter. It's kind of like our 1, 2, skip a few, 99, 100. They're admitting I skipped from 0 to 300, but now I'm going to go up by nice even numbers up by 25 is the rest of my scale. That is okay. The period number they just labeled 1, 2, 3, and then they plotted their points. They've got a nice title, When Students Eat Lunch. The vertical is our dependent variable, number of students, and the horizontal is our independent variable, the period. A set of ordered pairs like those in example 4 is called a relation. The set of the first numbers of the ordered pair is the domain. The domain contains all the values of the independent variable. The set of second numbers of the ordered pair is called the range of the relation. The range contains all the values of the dependent variable. Mr. Marr is taking his biology classes to the zoo. The zoo admission price is $4 per student, and at most 120 students will go. Identify a reasonable domain and range for the situation. Now the domain's pretty straightforward. They say there are up to 120 students going. You can't have a negative number of students, so the domain could be anything from 0 to 120. The range contains the total admission price. Okay, again, you can't have a negative admission price. That doesn't make sense. So the range could be anything from 0 to 4 times 120 or $480. And that estimate is helpful for us to make a graph. Draw a graph that shows the relationship between the number of students who go to the zoo and the total admission price. Okay, again, we've got a nice label, total admission cost, and this time they did not skip a few, so they just went by hundreds on the vertical scale, and they went by 40s on the horizontal scale. And we'll start off plotting those two basic points we have given in our domain and range. We're going from 0, 0 to 120, 480. So there's 0, 0 and 120, 480. And drawing a line to connect those points would be helpful to help us predict the cost for any number of students. Graphs can be used to represent a function and to visualize data.